All right, moving on in Chapter 16, Section 2. Let's look at, instead of just two individual charges, let's look at multiple charges. In this example, three charges. We have charges 1, 2, and 3. The first thing we need to do is just identify the forces. And when I say identify, I mean let's just name them. So if we look at what force would be acting between charges 1 and 2, I would call that force 1, 2. Or force 2, 1, that would mean the same thing. If I look here between charges 2 and 3, I would call that force 2, 3 or 3, 2, and here force 1, 3 or 3, 1. Either way you write them, they would mean the exact same thing. A couple things to understand. Force 2, 3 would be calculated using Coulomb's law, Coulomb's constant times charge 1 times charge 2 divided by the distance squared. Force 2, 3 would not at all be influenced by charge 1. It would be 100% independent. Coulomb's law always only has two charges in it. We cannot calculate Coulomb's law using three charges. It simply won't work. So if you're doing force 1, 2, you are only using charges 1 and 2 and the distance between them. Please understand, the force of 1 on 2 is the same as the force of 2 on 1. They are having an equal and opposite force between them. Turn the page. Now that I give them some quantitative data here, let's calculate the forces acting on each of them. So I want you to pause the recording in a second and use Coulomb's law here. Electric force equals Coulomb's constant times charge over the distance squared. Now here it could be charge 1 and charge 2 and the distance, or charge 2 and charge 3 and the distance, or charge 3 and charge 1 in the distance. So go ahead, pause the recording, and calculate these three values. Go. I'm going to pause. And we're back. So you will have calculated right now, and you will have found, let's see, charge 1, 2 will be a smaller charge, 26.97 newtons. That's charge 1, 2. Notice that you got 2 meters here. It's a little more than these. And the forces or the charges are just a little bit smaller than ones involving number 3. And I say that because, look, force 2, 3, which has the largest pair of charges and a small distance, is considerably larger. And then force 3, 1 is considerably larger, 719.2 newtons. So we've gathered up our data. Now we're going to make use of that data. On the next page, we're going to move this charge over to here and this charge over to here. So our forces that we have written on this page, force 3, 1 will remain the same at 719, and force 2, 3 will remain the same at 95.89. Let's turn the page. And here, same charges, these same distances. So like we said, let me jot this down. And I jotted these down. This one was recorded from the other page, as was this one. This one's new because now the distance between 1 and 2 is no longer 2 meters. Now the distance between 1 and 2 is 3 meters across from 1 to 2. So now we've got our raw data. Let's start working with it. Calculate the force acting on each of the charges. Now find the net force on charge 1. So we need to ask ourselves, we're looking for net force. Net force is always going to be the sum of all forces acting on something. So we have to think, what forces are acting on number 1? Let me switch colors on my pen here. I would say force 1, 3 is certainly acting on number 1. And force 1, 2 is certainly acting on charge 1. But we have to ask ourselves, is force 2, 3 acting on charge 1 at all? The answer is no. Force 2, 3 is just between these guys, not involving number 1 at all. So if you want net force, excuse me, you have to now look at and say, what are these forces doing? And because they're all the same charge, they're all repelling. So force 1, 3, it would seem to me that number 3 is repelling number 1. 1, 3. Sorry, I'm drawing with the mouse, so my numbers are a little goofy right here. Force 1, 3. And force 2, 2, 1, or 1, 2 would also seem to be repelling. 1, 2. They're both repelling, so they're both pushing the same way. So you have to ask yourself, would these two forces then add up or subtract from each other to find the net force here? Think about that for a second. Hopefully you decided that they're going to add up because they're both doing the same thing. They're pushing this one away. Therefore, we would add 719.2 and 11.99, and you're going to get roughly, we're adding 12 to 719, so roughly 731 or so. There'll be a little change there. So we'd add those up to get the net force acting on number 1. So let me kind of clear this out here. What if instead I asked you for the net force acting on number 3? We have to think a little differently then, because we have force 1, 3 is pushing this direction. Force 2, 3 is pushing 3 that direction. Imagine 3 kids sitting in the back seat of the car. And 3 kids are always pushing and pulling on each other in the backseat of the car. They never get along. Little kids, 5-year-olds. You get 3 5-year-olds on the way to soccer practice. Kid 1 is pushing on kid 3. Kid 2 is pushing on kid 3. These two forces are acting in opposite directions. So we'd have to subtract those two forces from each other because they're going opposite directions. If we instead considered the net force on number 2, we'd say 1 is pushing on 2, and 3 is pushing on 2, and. So we'd have to add those up. Something we're going to think about whenever we do a net force problem. So let's look at what our assignment is going to be for this activity here. It is not, I thought I changed that. It's 558. 558, I thought I changed that. I hit reset. It's 558, 1 and 2. For number 2, you got this. They're going to give you this square. I want you to take the top charge, bring it down here, keep the distance the same. Take this top charge, bring it down here, keep that distance the same. Essentially making 4 charges in a row and calculate there. Now, of course, any answers in the book will not be the answers that we are looking for. I don't want you to do them in a square. I want you to do them in a straight line. There's going to be a lot of individual calculations here on this problem, but you can handle it. That's why you're only getting 2 problems in the assignment. All right. Good luck with this assignment.